Problem 7. The concentration of gallium in silicon is 5 into 10 raised to the power minus 7 atomic percentage. What is the concentration in kilogram of gallium per cubic meter? So in this case, the concentration of gallium is given. So we take it as C1 prime is equal to 5 into 10 to the power minus 7 atomic percentage. So therefore we can calculate C2 prime, which will be equal to 100 minus 5 into 10 to the power minus 7. So this will be equal to 99.9999995%. Okay, so this atomic percentages can be converted into the mass percentages or the weight percentages by this equation. So for example, if I want to convert the for gallium, and gallium I'm showing by 1, so it will be represented by C1, okay, without this prime. So it will be equal to C1 prime multiplied by the atomic mass for the gallium, and it will be C1 prime A1 plus C2 prime A2. So now A1 is the atomic mass for gallium, atomic weight for gallium, which is 69.72, and A2 is the atomic weight for silicon, it is 28.09. Okay, if you want it in the percentage terms, so then we'll multiply it with 100. Okay, so input these values. C1 is 5 into 10 to the power minus 7 multiplied by 69.72 divided by 5 into 10 to the power minus 7 multiplied by 69.72 plus 99.9999995 multiplied by 28.03. So in this way we will get a value of 1.24 into 10 to the power minus 6 weight percentage. Well, this is to be multiplied by 100 for the percentage. Okay, this part. So this weight percentage can be converted into the kilogram per cubic meter by this expression. So C1 double prime will be equal to C1, this percentage, divided by C1 over rho 1 plus C2 over rho 2. And rho 2 are densities. So suppose if the densities are in gram per cubic centimeter, so we can multiply it with 1000 or 10 to the power 3 to convert these values into kilogram per cubic meter. So the density of gallium is, it can be found from the tables, it's 5.9, and the density of silicon is 2.33. So both are in gram per cubic centimeter. So input the values. C1 we have already found, which is 1.24 into 10 raised to the power 6, 1.24 into 10 to the power minus 6 by weight percentage, divided by C1 1.24 into 10 to the power minus 6 divided by 2.33 divided by 5.9, and C2 is equal to 1 minus C1. So it can be put like this: 1 minus 1. Okay, so because this is in percentage, so instead of 1 you will take 100 minus 1.24 into 10 to the power minus 6, and then divided by the density, which is 2.33 gram per cubic centimeter, and then multiplied by 10 to the power 3 or 1000 to convert it into kilogram per cubic meter. So in this way you will get a value of 2.89 into 10 to the power minus 5 kilogram per cubic meter. So which means that in 1 cubic meter of silicon gallium composite, the amount of gallium will be this much: 2.89 into 10 to the power minus 5 kilogram. So if you convert it into grams, so you multiply by 1000, so it will be 10 to the power minus 2, or so it will be 10 to the power minus 2, so it will be 0.0289 gram per cubic meter. Okay, so it's relatively very low quantity in the volume of gallium silicon.